All right. 6.2, measures of spread. So the key with this is that we need to go through some definitions and measures of spread. The definitions include words like percentile rank, which is rank is equal to percentile over 100 times n plus 1. Now percentile is the percent of all the data that are less than or equal to a specific data value. N is the population, okay, population size, and R is the whole number rank rounded down. So percentile is calculated by taking 100 times the L plus 0.5 times E all over N. Where P represents the percentile and L represents a number of data less than the data point, and E represents the number of data equal to the data point, and N is the population size. So L is the number of data less than the data point plus half of E, E being the number of data equal to the data point, divided by the total population size. So we also need to know what these words mean. So one more time, percentile means the percent of all the data that are less than or equal to a specific data value. We also have words like quartile, range, interquartile range that we also need to have the definitions for. Example 1. The mean playing times per game for 22 hockey players on a game are given. So these are the average playing times for each hockey player on a specific team. And what we're to do with this is to gather some information from here. We're to determine the 40th and 95th percentiles. Basically, 40th and 95th percentile. 40th means the 40th percent rank, whereas 40% of the data will be below it, and 60% of the data will be above it. And 95th percentile is the same idea. 95% of the data is below it, and 5% of the data is above it. So, to do this, we need to look at the formula. R is equal to P over 100 times N plus 1. We want to know what there are. P is the percentile rank that you're looking for, which is 40th in the first one, over 100, times data is 22 plus 1, so number of population plus 1, and we calculate the rank position. So that means the 9th player in order would be the 40th percentile. So 40th percentile is between the 9th and 10th values. The 9th and 10th values, when we find it, going here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So between these two numbers, 16.4 and 16.7, divided by 2. So the 40th percentile has an average mean playing time of 16.55 minutes, or times per game. Yes. Next, 95th percentile, you take 22 pieces of data plus 1 times 95 over 100, means that we will have 21.85, which is always rounded down to 21. So 95th percentile is the values between 21st and the 22nd place. So 21st and 22nd number in the data. So when we had, this was our 9th and our 10th, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So between these two values, 21 and 22, we will find the 95th percentile. 95th percentile turns out to be 23.85 minutes per game, or times minutes per game. So 95% of the people on the team achieved 95% of the team achieved 23.85 minutes per game. 40%, between 40 and 95. These are the values. Most players achieve between 16.55 minutes to 23.85 minutes. All right, moving on. Part B, determine the percentile of the player who averaged 21.7 minutes per game. So we want to know what rank do they fit in if they did 21.7 minutes per game. Well, I know my percentile rank is done as follows. 100 times 17 pieces of data was under 21.7. So looking back at the previous screen, we need to find out how many players were less than this value. So going back, all of these players were less than these values. All of these players right here were less than these values, so we count the number of values there. We also had 2 players that received 21.7. So when we go back to that part in the question, what we need to do is add 0.5 times E. E is how many players had equal value. So there were two players that received an equal value of 21.7 divided by 22. 22 is the total number of players. So 17 players were below, and there were 2 players that had an equal value, and then we divide by 22. Well, a percentile value will be 81.8181, the percentile rank. So the person was in the percentile of 81.8181, so 82 percentile, 82nd percentile. That means in terms of position, they were in the 82nd percentile, which means that 82% of the people achieved less than them, up to them, and 18% achieved more than them. Example 2. Determine the mean, median, range, first and third quartiles, and interquartile range. Make a box and whisker plot of the data. Describe the data in each zone of the plot. Identify any outliers if they exist. So let's pause this for a minute. Okay, so a summer camp activity involves measuring the distance traveled by 50 turtles in 15 minutes. The table shows the results. So, in 15 minutes, there was 1 turtle that traveled in this distance, and so on. So these are ranges for the distance. And the frequency that occurred is, here it is on this side of the table. And the total frequency should equal 50 because it's 50 turtles that were compared. Now, what you have to do is determine the cumulative frequency to make sure that we have all our data. So we have 50 pieces of data, folks, and that is the total number of turtles. So this information matches. We're not missing any information. But what we need to do is find the middle, the median. The median, because this is ranked in order, will be the middle value. The middle value is calculated by taking the cumulative total, which is 50, which is the 50th percentile is another way to do it. And the 50th percentile of the median is 50 over 100 times 50 plus 1. Another way to do it is you take 50 plus 1 divided by 2 to find the middle, which is about 25.5. 25.5 fits in this cumulative frequency in between here and here. In fact, after 19, but before 34. So that means in the 20 to 25 meters, the half the turtles traveled between up to 20 to 25 meters, and the other half of the turtles traveled up to 45 meters. So here we go. So it's about 22.5 is the median value. We can't use a middle range. What we do is we find the median of the range that you're given, or the range from 20 to 25. You find the middle value. So that's like finding the midpoint. And so 22.5 meters was the median. The range is what repeated the most, and that also turns out to be the same distance. Okay, the mode was the same, 20 to 25. Our range here value, folks, if we calculate the range from the midpoint of the first distance to the midpoint of the last distance, 42.5 minus 2.5, turns out our range is about 40 meters if we calculate the range from the midpoints. If we calculate the range from the lowest value to the highest value, that range is 45 meters. So again, it depends on how you calculate the value and the way it asks you to calculate. So the range here ranges from the lowest to the highest, which is 45 meters. The range of the midpoints is about 40 meters, folks. We need to calculate the first quartile. To be able to draw the box and whisker plot, we need to calculate the first quartile. We have the middle, median, and we need the third quartile. The first quartile is calculated by calculating up to the first 25% of the data. 25 over 100 times 50 plus 1. The first quartile is about 12.75, which is the 12th number to the 13th number, the 12th to the 13th in that table. So let's go back to that table. Means that it will be 17.5 meters. So we'll go back to the chart and come back to this one in just a second. Let's go back to that chart. So the 12th and 13th piece of data is found between the 7, after the 7, before the 19th. So our 12th to 13th piece of data is found here in this range. So that is our first quartile. So that will be 17.5. That is the midpoint of that range listed. Then the third quartile is calculated in the 75th percentile, which is 75 over 100 times 50 plus 1, which is equal to 38.25, which is the between the 38th and 39th position in the table. So let's go back to that table for a second. So we can see in the 38th to the 39th should be right here. So again, this is our third quartile. The midpoint between 25 to 30 is 27.5. So let's go back. 38 to 39 is about 27.5 meters. So that's our third quartile. Our interquartile range goes from Q3 minus Q3 minus, okay, so the interquartile range goes from 27. So Q3 minus Q1, and that's the range between the third quartile and the first quartile, which turns out to be 10 meters is the range, interquartile range. So when we draw our box and whisker plot, we plot out the numbers from 0 to 50, and we know our data goes from 0 up to 17.5. Then at 17.5 is our first quarter, and that receives a box. And then from the first quarter to our midpoint, which is at 22.5, which receives another dot and our end of our box, we create a new box from the midpoint, the median, to the third quartile. We create another box, and what we've created here is our two boxes. So from Q1 to Q2, from Q2 to Q3, this is our box, and our interquartile range goes from Q1 all the way to Q3. That interquartile range is the width of this box, and then we continue the box onto the other side to the highest point in the table. So this is known as a box and whisker plot. The box in the middle refers to Q1, Q2, and Q3. Now, not always, is the does the box look like this? Sometimes the Q1 and the median could be over here, so you would have 2 dots on this side of a box and 1 full box. Sometimes the median is over here. Sometimes the median is closer to one or the other, again, depending on what data was gathered in the table. So you could have different box and whisker plots. Now, the outlier in this case is any value that is 1.5 values higher than the interquartile range or lower than the interquartile range from Q1 and Q3. So basically, values that are in this set of the data that is really, really low or really, really high, those would be considered outliers. So to calculate that, we need to find basically which outliers would be from here to here. So that is Q1 minus 1.5 times the interquartile range. The interquartile range is 10 meters. So Q1 was 17.5 minus 15, that's 1.5 times 10. 17.5 minus 15 means that 2.5, any values less than 2.5 are considered an outlier. And in our previous box, there were no outliers in that value because 2.5 was the lowest. So the lower outlier is 2.5. The higher outlier is Q3 plus 15, which means those values would be 42.5 would be the highest outlier. And let's look at our table once again to check for any outliers. We can see here that our data doesn't contain any outliers because 2.5 was the lowest in terms of the lower number value, and the higher number value is 42.5. So that is our higher value. So that is well within the values that are allowable. So therefore, we have no outliers in this particular problem. Okay, moving on. The box and whisker plots illustrate the spread of Canadian full-term male and female baby lengths in centimeters at birth. Compare the spreads of the birth lengths for boys and girls. Now these values here, folks, you would be given a little bit more information with regards to this. But the idea is to be able to compare them. So what we're doing is we're comparing the boys and the girls, the median, the range, the Q1, the Q3, and the interquartile range. So you'd be given values. You wouldn't be given some vague information like this. You'd be given more information and the box and whisker plot already drawn. So, for example, the median in both of these cases is one case, the male baby length is 50. The girl baby length is 49 centimeters, more or less, about 49 centimeters based on the scale here. Now, the range goes from 44 all the way up to 56. And the females go from 44 all the way up to 56, roughly. And it could be just a little bit less than that, but the idea is that it's not exact, it's higher than 55, but just a tad short under 56. So again, they have roughly the same range. Q1 is about 48.5. And how do you calculate that value? Well, you look at here and say, all right, my Q1, if we had the values, is about 48.5. My Q3, so 48.5 right here. Q3 would be about, if we're looking at the Q3, it's about 52. For the girls, it's 47.5, slightly less. And the boys, the highest is Q3, is 51. So again, you'd be reading the data that is found here, looking at the dots. The first dot in the box is Q1. The second dot represents the median. and the third dot represents Q3. These whiskers on either side of the box represent the entire range of the values for full-term births. Interquartile range is about 3.5 for both of these. Again, from here to here, you subtract it, which is 3.5 centimeters, and from here to here, you subtract it, and it's about 3.5 centimeters. So what you would do is be able to read a box and whisker plot and be able to analyze the data. Okay, last one. A consumers group recently tested 100 compact fluorescent light bulbs and recorded their lifetimes. The chart shows the results. We need to make a box and whisker plot of the data. So what we need to do is calculate the midpoint of each of the lifetimes, and we will need to find Q1, Q2, and Q3, and remember Q2 is also known as the median. So the range is from 5,000 to 12,000, which is about 7,000, or if you find the midpoint of each lifetime, we're looking at from 5,500 to be able to calculate to 11,500. And then we need to find the cumulative frequency of each of these values. We need to do that because we can determine the Q1, Q2, and Q3 values. So cumulative frequency of each value, we add them all together. It has to equal 100, so because there's 100 bulbs that were tested, Q1 is the 25th percentile of all the values, which is 100 plus 1, which is 25.25, which is between the 25th and 26th light bulb. 25th and 26th, when we're looking at the table, 25 to 26 means that these are all the values here, which is 7,500. Q1 is located in between 7,000 to 8,000 hours. Then we need to calculate the midpoint, the median, which is 50 over 100 times 100 plus 1, which is 50.5, which is between the 50th and 51st value. That will be also found in the same place where Q1 is found, so our median, our Q2, is found also in the same place where Q1 was located. And then Q3 is 75 over 100, which is 100 plus 1, which is 75.75 or 75th, between the 75th and 76th position. 75 to 76 is actually found in this value. So 8,500 turns out to be Q3 for us. The interquartile range goes from 7,500 to 8,500, which is 1,000 hours. That is our interquartile range. There's only 1,000 hours between the between Q1 to Q3. So when we draw a box and whisker plot, we're going to have values of 5,000 all the way up to 12,000. And we're going to draw our Q1 and our Q3 box with our Q2. So our Q1 and Q2 to Q3, we have two dots on Q1 to represent our median, our median and Q1, so our first quartile. And then our Q3 will have one dot. And this will represent our box and whisker plot, folks. So we have two dots and one dot, and again a whisker on either side, going from 5,000 all the way up to 5,000 all the way up to 12,000, or 5,500 to 11,500. Now, what's important here to note is, are there any outliers with respect to this? Are there any outliers? And yep, there will be. And why will there be? Well, we need to calculate them. How do we calculate them? We take the median, our Q1 value, and subtract 1.5 times the interquartile range, which is 1,000 hours. And we take Q3 and add 1.5 times the interquartile range. So we get 7,500 minus 1,500 means that if any particular lamp is less than 6,000, means that that is an outlier. So there were 7 bulbs that were an outlier because they were less than the 6,000 hours. And then when we have the upper end, do we have any outliers? Yes, we do, because our Q3 was 8,500. We had 1,500 hours, and that's 10,000 hours. Do we have any that were more than 10,000? And yes, we do. Those ones that were more than 10,000 hours, there were actually 10 of them, 10 light bulbs that were more than 10,000 hours, and those turned out to be our outliers on the higher end of the outliers. Okay, well, that's the end of the video, folks. Have a numerical day.